Alright, I stand by everything in this video not being exactly 100% precise, but from where I see it, you have, it's just a bunch of special relative, like a special relative argument would be um, just the moon's gravity against Earth's gravity, or the moon orbiting Earth and the perception of gravity from that standpoint. And you could say that there is a transfer of uh, like atomic polarization. There shouldn't be any exacts, I guess, but I, and then, if you have a general relative perception of the moon orbiting Earth, then you'd have to have some sort of uh, definitive way that it happens over time, I'd say. And that's when it gets tricky, because you have to include basically like another variable, and that variable of time is very just extreme in just vulnerable space. So they use this word called ward state, and I'd say that's like just an atomic nominal state where you have a certain amount of atoms and everything around you has a certain amount of atoms, and that's how they can force things like a Lorentz force. I don't know if the dielectric field, I think, is not too perceptually different than uh, the Lorentz force. Because again, this free energy is going to come from some sort of constant, or some sort of thing that we think is constant, like the sun, like a solar panel, or again, like carbon from humans, like in the form of waste. So we always perceive that we're going to have some free form of energy, and then that's how they create something geometrically sound, like as if there is some constant polarization. Now, if that constant polarization is happening within, like in a special state or an award state, then you can see that. But when you take it to the next level and you look at the moon and the sun and how the orbitals are happening, then they have to say, well, it's a dielectric field within a geodesic magnetism or something. I don't know. Like there's not really meant to be a final answer, unless again they just talk about that ward state, and that ward state seems pretty perceptually real. Again, you just have electric force through plus electric force plus magnetic force equals your force. So yeah, you could say dealing with forces, you're going to be more in a ward. You're going to be looking at the space in a sorry, you're going to be looking at space in a special relative state that isn't going to be really conclusive in terms of what happens to it over time. There's not going to be an answer for that. So one answer that quantum physics will have is, well, let me get to the rope hypothesis. So the rope hypothesis is, I'd say, almost exactly like string theory, except it is without it is without the actual the photonic manipulation. So so in string theory, photons they can manipulate the energy, it seems like, and in rope hypothesis, you just have one constant, and there is no manipulation of the electrons or the atoms in the said field. So it's just it's just string theory, basically. Because yeah, again, how can you? I mean, you can't have tears. There can't be tears in space, like you can't have tears in space-time. So the idea with string theory is that there's going to have to be manipulation of the energy, like through maybe photons are smaller, are meant to be small. Maybe the particles of photons are meant to be smaller than the electrons, and they manipulate the quarks. I think that is what is happening, and the quarks have to be antimatter because there has to be again that manipulation going on. So again, I don't know if this would be able to tell for like general time, like what happens generally over time. So he seems to know everything that's going on, like all the big well, I mean, yeah, all the whatever conspiracy people. Still, I just don't know how this is going to be any different than string theory. But yeah, it'll be some. It just has to be like some special, special ward, special ward state going on. Again, because you're trying to. I mean, you're not just. Again, like special relativity and general relativity, they can happen in one isolated, like a room. They can happen like in one of like dense, field that is just in my room. It doesn't have to be all over space, but it's when you're having just, I would say, an isolated sort of rhetorical. Gravitational background, and then you're actually having to incorporate everything in the field into it, and that's when I'd say that you're going to run into mathematical problems. And in this case, unapologetically, yeah, I think the logic isn't going to be fully sound if the mathematics isn't fully sound. Since that's what we're kind of discussing out here. So, I mean, people talking about how they have a completely sound, valid description of the universe, as if like that's not what we would be trying to use. But again, they're doing it from this perspective or point of view that is, yeah, it's just a little bit, it's a little bit weak, and it doesn't have time. So I'd say it doesn't have time, and I'd say if you don't use time in a problem, then yeah, you're just going with like atoms are in everything, like just some Greek philosophy that atoms are in everything, and just saying, oh well, they're opening the portal up to demons and Holy Ghosts, and I wouldn't say that's true. I would say that like those, I don't know, people. I don't think that's how Newton sounded when like his theory was getting taken over as if it was some fucking sport. So I think that's pretty weak, substantially weak. Yeah, just because most of the physicists today, they especially know that we are fucked. So I don't really think there needs to be, an argument over bells and whistles or what have you. So yeah, dielectric field. I don't really see how it's any different than the Lorentz force. And again, they're going to be getting their free forms of energy from what they think are free forms, which really aren't going to be free forms, such as the sun or water or however you're getting these, because they're calling it a dielectric field because they're saying that Earth is resting in a dielectric field, but just because it is okay right now doesn't mean that it's an infinite form of energy. And that's kind of the presumption there. That's kind of like the conspiratorial presumption. I mean, other than just the sort of Greek way of looking at things, like everything's made up of atoms and you can't do anything about it, and that's how we have our universal concourse, or that's how there is any energy possible, and that's how the chemicals are made up, or the elements are made, and the chemicals are made, and the effects of light, and it's all from everything just being involved with atoms. Well, I'm just saying you can't take any there's nothing you can do about technicalities with that in terms of trying to understand the frequency or the wavelength or whatever you guys don't call it that happens, how that is manipulated over time. And I think it seems like a good way to be able to distinguish that is with a microscopic string theory, and your strings are just in relative to the, I sort of like the word counter space or antimatter. I'll go with counter space right now, but yeah, so that counter space can be manipulated when there is photonic light that is from the sun or electric in itself. Then those electrons can get manipulated through these microscopic strings. I think that's how it was described recently. And so, yeah, I mean, your difference between the rope hypothesis and string theory is very little in that sense, in that the strings are going to be so small, but they are going to be manipulated. I guess they can be manipulated on a massive scale if you're looking at the space that way, but there is going to be manipulation. Okay, so that means there's going to be another dimension, and just in terms of time, just in terms of the scale of time having to be on an infinite scale like that, it's sort of a necessity if you're going to be describing these things across space. And if you're not going to be describing them across space, then you're having an isolated experiment, and it's not going to get anywhere. I mean, it's the same. It's saying the exact same thing. You're just using all things are made up of atoms, and so even in that sense, you're pointing out that all things are made up of atoms, and you're made up of atoms. So I mean, I don't see how it makes any difference. So that's about it.